How to add and subtract rational expressions. Again, everything that you've learned how to do with fractions comes back into play here. For example, if we had a fraction like 3/8, one of the first things you learn how to do with fractions is learn how to write them with other denominators, so that you can, when asked to, take a fraction and rewrite it with a least common denominator. Let's say this first fraction need to be rewritten with a denominator of 40. Now if you look at the 40, you see that 40 is just really nothing more than an 8 times 5. So what the 8 doesn't have that it needs to become the 40 is the 5. So when we convert a fraction to a different denominator, we do that just by multiplying the fraction, top and bottom, by whatever it is that's missing. And that's going to be the principle that we use. For example, if we had an A over an A plus B, and we wanted to rewrite this so that it was over an A squared minus B squared, what we have to figure out is, what do you multiply A plus B times to get A squared minus B squared? Well, if you look at the factorization of A squared minus B squared, it's A plus B times A minus B. So it's the A minus B that we're missing. So we will take the first fraction, multiply it only by what's missing, and we get our new fraction with the correct denominator. Okay, and this technique is something we're going to have to bear in mind whenever we run into a fraction that doesn't have a least common denominator already in place. Now let's start off our addition and subtraction examples, though, with some fractions that already have common denominators in place. A very crucial thing to remember, and the reason I'm starting with a subtraction problem, is that first of all, when you subtract, you're subtracting the entire numerator. So you might want to, in a subtraction problem, insert grouping symbols here where the book often leaves them out. So this becomes a 2x minus an x minus 1. Also remember, when you're adding and subtracting, the answer gets the common denominator. Alright? Now here, I have to distribute the minus sign, and I end up with 2x minus x being x plus 1 over x squared minus 1. Now the last thing to remember about your addition and subtraction problems is that you always have to look to see if it is possible to simplify. And as we learned with simplification, you can't simplify if you haven't factored. So if this problem, factorization, shows us that that problem could be simplified. Alright? Now that was an example where a common denominator was already in place. Let's do one where we don't have, and we'll start simple, but let's look at a problem where common denominators weren't already there for us. In this particular example, we've got a y squared for one denominator and a y for the other. And the question is, what's the LCD? Well, I can't multiply y squared by anything to get a y because the power is smaller. But I can multiply a y and get a y squared, so that's what I need to do. So I'll multiply top and bottom by y. So now that I have a common denominator, I can actually do the subtraction and put that together. Now since nothing here will factor, I don't need to worry about any kind of reduction. Let's look at another problem, sort of stepping up the level of difficulty, where we don't have a common denominator in place, so we've got to get one. Let's look at 4 over x minus 5 minus 3x over x squared minus 25. Now, the first fraction has a denominator that can't be factored. The second fraction, its denominator can be factored to an x minus 5 and an x plus 5. And again, if you're figuring out what's the LCD, we'll sort of make a note of it to the side here. The LCD's got to have the x minus 5. It's also got to have the x plus 5. I don't need another x minus 5, even though you see it in two different places. Neither denominator has more than 1. So all I need to multiply by, top and bottom, is by the x plus 5. So distributing, I get a 4x plus a 20 minus a 3x, and of course it's all over the x minus 5 and the x plus 5. Combining like terms, I get an x plus 20 over x minus 5, x plus 5. Everything is factored. Nothing will cancel. Therefore, I am finished with this problem. Now let's jump down to a clean piece of paper and do another problem just like this one. Let's look at x over x squared plus 5x plus 6 minus 2x over x squared plus 2x. Now again, I can't look at this and see what the LCD is going to be until these things are factored. Now I've got the habit, I like to sort of drop down here below the original denominator, do my factorization there so I can see my factors more clearly. X squared is x and x, plus and plus, 3 and 2. So I already know for this problem, least common denominator has got to possess an x plus 3, also has to possess an x plus 2. In this next one, I can factor out an x, and it's an x and an x plus 2. The x I don't already have, so I will add that to the LCD. X plus 2 is already accounted for right here. So looking at the denominators that I have, and looking at the denominator I'm supposed to have up here, I see the first fraction is missing nothing but an x. So I'll multiply it by x, top and bottom. So we get an x squared over x, x plus 3, x plus 2, minus the next fraction is missing the x plus 3. So I will write that both top and bottom. So we have a 2x and an x plus 3. And now both fractions have the common denominator. Now I sort of waited, again because this was a subtraction problem, and let's look now at how we're going to go about combining these like terms. It's going to be an x squared, and I'm going to distribute a minus 2x. So it'll be a minus 2x squared minus a 6x on top over the x plus 3, and the x plus 2. And then x squared minus 2x squared will be a minus x squared minus a 6x over the x plus 3, and the x plus 2. Now, I would factor the top, and a negative x would factor out. So I'll do that. And left behind is an x plus 6. And on the bottom we've got the x plus 3, the x plus 2. The x's cancel. And there's a negative x minus 6 left when I multiply the negative back out, with an x plus 3 and an x plus 2 on the bottom. So that's the basic principle behind how the addition and the subtraction work. I think it might be beneficial, though, to us to look at least a couple more examples to make sure we have a good handle on what's going on with those. Let's look at 1 over 1 minus x plus x squared over x minus 1. Now something that's come up before is this 1 minus x and this x minus 1. Remember, they're not the same, so I don't have a common denominator here, but they're very close. They're simply the opposite of each other. So what I can actually do is multiply this fraction, top and bottom, by -1, and I get a -1 over an x minus 1 plus an x squared over an x minus 1, and all of a sudden I find myself with common denominators. This gives me x squared minus 1 when I put the variable up front over an x minus 1. Of course, this numerator can factor. When it's factored, we have cancellation with a simplified answer. Alright, now let's try this again. One more time, making sure we can factor and combine like terms correctly. I think we should use a piece of paper here. Let's look at x plus 2 over 6x squared plus 13x plus 6. From that, we're going to subtract 1 over 2x squared plus 3x. And again, we do not know what the LCD is going to be until we get some factoring done. On the first denominator, it's a trinomial that will factor into two binomials. And let's try for the 6x squared a 2x and a 3x. And for the 6, let's try a 3 and a 2. And what's that going to give us? With a plus and a plus, 3 and 3 is 9, 2 and 2 is 4, 9 and 3 is 13. Yes, so 2x plus 3, 3x plus 2 is going to be a part of the LCD. Now on this one, an x factors out, and you're left with a 2x plus 3. The x I'm missing, the 2x plus 3 is not missing. So, let's come over here so we can see this next step more clearly. The first fraction is missing nothing but an x. So I'm going to have x times x plus 2 over the x, the 2x plus 3, and the 3x plus 2, minus. The next one is missing the 3x plus 2. So we'll multiply that top and bottom. Remember, you're multiplying only by what's missing. So this is going to be a -1 being distributed, so this is going to be minus 1 times the 3x plus 2 over the x, the 2x plus 3, 3x plus 2. Now I'm going to distribute. Distributing first, I'm going to have an x squared plus a 2x minus a 3x minus 2 all over the x, the 2x plus 3, 3x plus 2. Now, only question left is combine like terms and see if I can simplify. This is going to be an x squared minus x minus 2 over the x, the 2x plus 3, and the 3x plus 2. Now let's see if factorization is possible. That trinomial might factor into two binomials with an x and an x, a 2 and a 1, a minus and a plus. And it does factor, but it doesn't reduce, so we're finished.